Writing the exact same line of code over and over again is not just incredibly boring, it is completely exhausting for any programmer. Copying and pasting identical instructions to perform a repetitive task introduces typos, makes your file enormous, and slows down your overall software. This diagram shows the loop, a structure designed to automate repetition. Instead of manually typing a print command 5 separate times, you type it once. A loop keeps cycling through your instructions continuously, as long as a specific condition remains true. But computers are literal machines. You have to tell them exactly when they are supposed to check if that condition is true. Do they check before they run your code, or after? Understanding when that check happens dictates how a computer makes decisions. It is the core logic behind the two main types of loops in C++. The first type is the while loop. You can think of it like a strict bouncer at the front door of a club. You must prove you meet the requirements before you are allowed to take a single step inside. This flowchart illustrates its core operational logic. Check first, execute later. The program evaluates your condition right at the start. If the condition is false, your path is blocked. In C++ syntax, the while keyword and its condition sit right at the top of the block. It acts as a gatekeeper, standing directly in front of the count, or print command, nested inside. Because of this top-down structure, if your starting condition is false from the very first millisecond, the loop is completely bypassed. The code inside runs 0 times. Programmers use while loops for unpredictable situations. For example, when reading a text file, the system needs to verify that the file actually exists before it attempts to extract any data. The second structure is the do-while loop. Imagine a funhouse slide that has no front door. You fall straight into the ride, and you only meet a guard at the bottom who asks if you want to go again. This diagram shows the inverse of our previous logic. Do first, check later. The computer executes the instructions immediately, before it ever asks if it should repeat them. The C++ syntax forces entry using the do command at the top, while the condition is placed at the very bottom of the code block. This creates an unbreakable rule. Because the evaluation happens at the exit, the code inside a do-while loop is guaranteed to execute at least one time. This makes it the standard choice for interactive programs. On a secure login screen, the user must see the interface at least once before the system can evaluate their credentials. The actual physical work being performed inside the computer is identical whether you use a while or a do-while loop. This illustration shows the functional difference between the two concepts. It all comes down to masa samakan, the precise time the check occurs. This comparison matrix shows how that timing directly dictates the minimum executions. An entrance guard allows for 0 executions, while an exit guard guarantees at least 1. This chart maps out exactly why different digital tasks require different loops. You use an entrance guard for reading unknown data, and an exit guard for displaying mandatory menus. If you need to guarantee safety before acting, put the guard at the entrance. If you need to force an experience before testing, put the guard at the exit. By choosing where that security check happens, you dictate exactly how your application evaluates data and interacts with the user.